This is Module 3, Lesson 1. We're going to be talking about distributing and combining like terms in an expression. So let's talk about what they are. Like terms are terms that contains exactly the same variables raised to the exactly the same exponents. So if we look at number 1 here, you will see that all of the little individual terms, and there are 3 of them, contain an x, and they contain a number in front, which is called a coefficient. So if I think about it in terms of pieces of paper with x written on it, I can say it's 3x, take away 2x, which is equal to 1x, and then what's ever left over, 1x, I'm going to add 7x to, and that's going to equal a total of 8x. So when we combine, we get 8x. 8 is called the coefficient, and x is the variable. Okay. Now let's look at the next expression. It's an expression because it's really not an equation. It doesn't have an equal to and stuff on the other side. So I'm going to do something called distribute first. I'm going to take that 2 and multiply it through. So I will get 6x, because 2 times 3 is 6, and 2 times 11 is 22. Take away 7x plus 12. Notice how the distribution stops at the end of parentheses. So now we're going to see which terms are alike and which terms are different. So 6x is alike to negative 7x. 22 is not alike to them because there's no x in it. So if we do 6x take away 7x, we'll get a negative 1x. And now we're just going to clean up the rest. If I have a positive 22 and a positive 12 and I add them up, I get a positive 34. And that's it. That's the answer. We've simplified and combined like terms. Look at part B in number 2. We're going to distribute, but this time we're going to distribute a negative number. That's a negative 3 through. So we have to be really careful about negative times negative is positive and things like that. The x plus 8 have nothing to do with it. And then I'm going to subtract 3x, because negative 3 times x is a negative 3x, and negative 3 times a negative 12 gives me a positive 36. But I'm not done yet because I haven't combined my like terms. So we see an x, we see a negative 3x. Notice how I'm taking the signs with them. And x is really a regular 1x, so I have one piece of paper with x written on it, and I owe you 3 pieces of paper with x written on it. So I still owe you 2 pieces of paper with x written on it. Now let's clean up what we call the constants. 8 is a constant because it doesn't have any variable attached to it. I want to make these look a little different. 8 and 36, we're going to add those up and we get a positive 44. Now let's look at linear equations. And what are they? Well, a linear equation in one variable can be written in the form ax plus b is equal to c. A, b, and c are just real numbers. A can't be equal to 0, otherwise it's just an equation of constants. X is the variable. Now sometimes it's y or z or q. So this equation, x minus 3 equals 10, is linear because x is just a single variable x. But the equation x squared minus 9 is nonlinear because it has an exponent on the variable of 2. By the way, the exponent on the regular x here is just a 1. So now we're going to talk about certain properties, and then we're going to use them. The addition property of equality just basically says I can add the same number to both sides of the equation and not impact its equalness or equality. And the multiplication property is exactly the same. I can multiply both sides by a number, except for 0, and still have the equal work and then be able to figure out what x is. If I multiply both sides of an equation by 0, I'll get 0 equals 0, but it's not going to help me solve an equation, and it's just going to throw a monkey wrench in the whole deal. So we are also going to be using the distributive property to remove parentheses, combining like terms on a side. We're going to move all the variables to one side and all the constants to the other, get a coefficient of 1 in front of the variable by multiplying or dividing, and then check the solution. So these are our go-to steps, and we'll go through them each time. Okay, so if we look at number 3, you can see that there is no distribution that needs to take place. So I'm just going to, and there's no combining like terms on a side. Think of the equal sign as your fence between sides, okay? Now, we need to move all the variable terms to one side. Well, we only have one variable, so we're like, yay! So we need to move the constant terms. Constants, again, are numbers that have no variable attached to it. So I'm going to add 3 to both sides because I want to get rid of it from the left side, add it to the right side. So just have an x here, -3, and a +3. When I add them, I get 0. 10 and 3 is 13. Now you might be saying to yourself, this is ridiculous. I could see what the answer was right off the bat. This is true, but we have to go through steps so that when you get more complicated problems, you can do the steps, find the solution. Let's do a check. So here's my answer. I'll be like super formal. My answer is x is equal to 13. Okay, now let's do a check. Now the formal check says you need to write the original equation down as it was. And then we're going to put 13 in for x because that's what x is equal to. We claim, that's our claim, we want to check 13 take away 3 is 10. Yay, we have a check. And we are right. And we know we're right. So we did a formal check with the bow tie. And now we're going to move on to another example. Okay, let's take a look at B. Well, there's no distribution to take place, but we can combine like terms on a side. 3y take away 2y is 1y. We need to get a coefficient of 1 in front of the variable y, and we did. We never, in math, I don't really care if you write the 1 in front of the y. It's fine, but in math, people are lazy. They just assume there's a 1 there, so y will equal 11. That's my little answer. And let's do a formal check here. If we do a formal check, we write down the original equation. Y is 11. So we're going to sub it in both places. 3 times 11 is 33. 2 times 11, 22, and yeah, that equals 11. I'm psyched. Checked. Okay, let's work on C. Well, this one needs a distribution, so I'm going to distribute the 4 through the parentheses. So I get 5x plus 1 is equal to 4x take away 8, because 4 times 2 is 8. Now I look to see if on each of the sides, again, there's my little fence, on each of the sides if we need to combine like terms. And the answer is no, because on the left-hand side it's a 5x and a 1, can't be combined. On the right-hand side it's a 4x and a -8, or 4x minus 8. So now we're going to start moving stuff. I'm going to get the variables to one side, and I love it when my coefficient in front of my x is 1. That's super great. So I'm going to move the 4x so I don't have to deal with any negative numbers. So I get x plus 1 is equal to -8. So now I'm going to go over here. X plus 1 is equal to negative 8. And now I'm going to get the positive 1 over to the other side by subtracting it. So x is equal to negative 9. So there's my solution. So I'm always writing my solution as the variable equals something. And I am not just writing negative 9. I'm saying x is equal to negative 9. I know I'm right. This one I'm not going to check. We're going to go on to the next one, which is similar to C, but we don't have as many steps. Well, maybe we have an equal number of steps. So what I'm going to do here is, I know it's shocking, but I can't combine like terms. I have no distribution to do. I'm going to move the variable, and I'm going to add 6x to both sides, because I really don't want to have to deal with negative numbers unless I have to. So this will be 18 on the left is equal to 14. Now I'm going to combine a negative 2x and 6x to give myself a positive 4x. So now I'm going to go over here. 18 is equal to 14 plus 4x. So now I have to get the constant over to the other side. So I'm going to subtract 14. 18 take away 14 is 4, and that's equal to 4x. Now this is the first example where we've had a number or a coefficient other than 1 in front of the variable. So I'm going to divide by 4, because what is 4 divided by 4? Well, it's 1, so I really end up with 1x on the right hand side, and the other side just happens to be 1 as well. So how should I write my solution? Well, this is fine, but I would like to get rid of the 1 in front of the x because it's assumed, and then I always like to write my variables on the left, and then I put a little box around it. Let's look at some more examples. These get a little bit more intense, but we only have 2 more. If I take a look at E here, you'll see that there's no distribution to take place. Remember your fence, you guys. Don't start panicking and moving things within a side. So here, if we look at the left-hand side, I can combine like terms. 3x plus 2x is 5x. And no, I don't have to change the sign because they're all on that one side. If I look at the right-hand side, negative 7 plus 11 is 4. And then the x just stays there. So now, and we of course have to put an equal to in between, now we have a situation where we can start moving things from side to side. So of course, guess what I'm going to do? I am going to put a 1 in front of the x, bring that 1x over as a negative 1x, and I will get 4x plus 8. I have not moved that 8 is equal to 4. I'm going to subtract 8 from both sides. So I'll get 4x is equal to negative 4. I'm going to divide by 4 on both sides. So x is equal to negative 1. Notice how I have my little 4 divided by 4. So that's a 1. It's assumed. I don't have to write it. I'm done. The last example in this section involves pretty much every single step in the equation solving process. First, I'm going to distribute on both sides here. You'll see here I have my little distribution arrows. So I have 10x, take away 5, take away 15, is equal to 12x plus 6 plus 4. Now I know that the 4 is not involved because remember your distribution ends at the end parenthesis. Now we are going to combine like terms on a side. So I'll get 10x, I owe you $5, I owe you 15, I owe you 20. 12x, I have $6, I have 4, so yay, I have 10 bucks. Now I'm going to move the x's. I'm going to subtract 10x from both sides. So I'm going to say negative 20 is equal to 2x plus 10. Now I'm going to subtract 10 from both sides. Going to bring them over. Take away 10. And now I'm going to move that result up here. So I get a negative 30 is equal to 2x. Divide by 2 to get a 1 in front of the x. So x is equal to negative 15. And I hate writing it like that, so I get x is equal to negative 15. Now you should be able to go on and do the homework section, the written homework section, and then the My Math Lab. Good luck.